Good morning, children. Earlier, I had sent videos regarding the 3 classes of liver. Today, we are going to start with the inclined plane, and you all must have seen the overbridges at the railway stations, and they have got stairs on both the sides. And in large stations, one overbridge often has slopes instead of stairs. So it has ramp instead of the stairs, and such slopes called inclined planes or ramps are used for moving loads. And ramps, they are used for moving loads. Hospitals, housing societies, and large post offices also have ramps for the movement of the wheelchairs and loads. So you have seen ramps are there even in our school, and these ramps, they are used to carry the loads because the load can be easily moved over the ramps then to lift up. Laborers engaged in loading and unloading trucks and railway wagons use thick planks to set up temporary inclined planes. You all must have seen the laborers who are used to load and unload the trucks. They make use of a wooden plank. Wooden plank is a fatta made up of wood, which they put one end they put on the truck and the other on the floor, and they are making use of it to slide the load over it. And the main advantage of an inclined plane over stairs is that the object can be easily rolled on it, and it is always easier to roll or slide an object than to lift it. So to lift an object is difficult, to slide is easier. So we make use of ramp for that purpose. And although the inclined plane is of great convenience, it is not really a machine, as it does not satisfy the definition of a machine. This inclined plane, of course, makes our work easier, but it is not a machine because it does not satisfy the definition of a machine. And the definition of machine says that the force applied at one end overcomes the resistance at another point. So when in a machine, when we apply force at one end, the work is done at the other end, or the resistance is overcome at the other end, and this does not take place in an inclined plane. And however, the principle of inclined plane is used in the screw, which is a machine. We make use of the principle of inclined plane in a screw, and screw is a machine. I hope you understand what is a screw. This is a screw. And next is wedges and a small piece of wood or metal which is thick at one end and thin at the other is called a wedge. So it is a piece of wood which is thick at one end and thin at the other end. And wedges are often used by woodcutters and carpenters for cutting and splitting the wood. So the woodcutters make use of the wedges, and even the carpenters for the cutting and splitting of wood. You are also these wedges, they are also jammed in the log being sawed so that the ends do not press in on the saw. So you all must have seen that when the wood has to be sawed means आरी से जब भी काटते हैं, then we make use of the wedges so that the ends do not get pressed in on the saw. Now a wedge can be used as a door stopper. You make use of the wedge as a door stopper. when you want to keep the door open, you make use of the door stopper, and that also is a wedge. When the thin end of the wedge is placed between the floor and the lower end of the door, it prevents the door from being moved. So it does not allow the door to move. Now, here in this figure 5.13, you will see that though a wedge is basically two inclined planes, these are two inclined planes. See, two inclined planes are there put together, and it satisfies the definition of a machine. And wedge satisfies the definition of a machine. Why? Because when we apply force at one end, the resistance is overcome at the other end. And knives, chisels, axes, and the needles are all wedges. So knives, chisel, axes, even your needle is an example of wedge. Now screw. To understand the principle of screw, cut a triangle out of a paper and wrap it around a pencil. You will see at once that the sloping edge of the paper looks like the grooves on a screw. And when a screw is rotated, the force acting on the head of the screw is transmitted along its grooves, and the screw thus winds into the material along the grooves. So when you apply force at one end of this groove, the force is transmitted along the grooves which are wound around this, and the screw moves into the wood. And the advantage of screw over nail is that one has to use less force to drive in than to drive in the nail. So the advantage of screw is that we have to apply very less force to drive it in the wood, but nail needs more force. And a blot rotating inside a fixed nut and a jack used to lift the car works on the same principle. You all must have seen when the car gets punctured, we make use of the jack to lift the car. And that also functions on the same principle of screw. And when the screw of the jack is rotated by the long handle, it gradually pushes the car up. Then a vise used to grip objects firmly in workshop is another common example of screw. This is a vise, and here the wood is put in the vise, and this is rotated, and it has a screw, and it can be tightened, and then we can saw it or even stick the sunmica and all with the help of this. And the object is held between the jaws of the vise. These are the jaws of the vise. One jaw is fixed, this jaw is fixed, while the other one moves when the screw is rotated by turning the handle, and the jaws can be made to apply large force on the object by turning the screw. So this vise is also an example of screw, and it makes our work easier. This is the jack which is used to raise the car. This also has an handle which has screw, and we rotate it and the car is lifted up. So this much for today.